welcome to the biological life sciences students. Today in this video we are going to see the details about solutions and the concentration of solution or different types of concentrations in which the solution are expressed. Okay, so let's see first of all what is a solution. Solution is a homogeneous mixture. It is a homogeneous mixture. Okay, it is a homogeneous mixture of two or more components. Okay, two or more components are mixed together, it forms the solution, and the particle size of the solution should be less than 1 nanometer. Okay, so it is a homogeneous mixture of two or more components in which the particle size is less than 1 nanometer. It is called as solution. Okay, so now today in this video we are going to see the types of solution and what are the constituents of solution. There are two major constituents of solution. First is solvent, second is solute. Now what is solvent? Solvent is the portion of solution. It is the portion of solution or proportion of solution which is present in major amount. This is present in major amount, or the concentration or the amount of the substance is more than it is called as solvent, and it dissolves the solute. Okay, solute can be 1, 2, 3 like that. Solutes can be 2 or more and it is dissolved in solvent. Okay, so the portion which is present in minor amount, okay, minor amount is called as solute. Okay, so now we are going to see different types of solution. These were solid, solution and solute, which together combines and forms solution. Okay, it together combines and forms solution. Okay, so now we are going to see what are the different types of solution that are studied based on the different constituents or the different matter. Okay, so we know that solution can be formed from solid, liquid and gases. Okay, so let's see the next heading, that is types of solution. Types of solution. Okay, so let's see the first type of solution, that is solid based solution. Here solid, first type of solution is solid solution, second is solid liquid solution, and third is solid gas solution. Okay, so now we will be I'll be quoting you one examples of each. Let's see the solution of solid or solid. Here the examples are alloys, bronze, brass. These are made from different alloys of different metals. So this is called solid solution, because here the metals are mixed in solid states. They are so mixed that we cannot differentiate between what type of metal are there, or we cannot separate that. Okay, so generally solid solutions are example bronze and brass. Okay, now let's see the solution that is solid liquid solution. This is the most common type of solution. Now here example, NaCl in water. Okay, when you mix NaCl, that is sodium chloride or salt, in water. Another example is sugar in water. Sugar in water. Okay, now this NaCl and sugar is in solid form and it is mixed in water. Okay, the third type is solid in gas. So here you can see iodine, when it is shaken, its constituents are present as a solid form in gas, air. Okay, in air, or camphor in air. Okay, when you burn camphor in certain pujas and all, the camphor turns into the solid particulate matter which is present in air. So this is an example of a solid in air solution. Okay, so now let's see liquid types of solution here. Liquid types of solution, second type, that is liquid. First type here is liquid in solid. Liquid in solid. Second, liquid in liquid. Third, liquid in gas. Okay, so we are going to see one example of each of one of them. So now liquid in solid, here the example is presence of mercury in amalgam, Hg, that is the symbol of mercury in amalgam. Okay, amalgam is the alloy that we fill in our teeth. Okay, whenever there is a root canal or whenever you do your root canal, so there is an alloy that is called as amalgam that is being filled as a filling in these teeth, and this is an alloy of mercury. Okay, so it is the solution of solid, that is mercury, in liquid, that is amalgam. Okay, that is an example of a liquid in solid solution. Okay, now liquid in liquid solution is obviously alcohol. Best example, alcohol in water. Okay, alcohol is miscible in all proportions in water, so it is the example of a liquid in liquid solution. Okay, the third is liquid in gaseous solution. Here you can take the example of perfumes spray, where the liquid is mixed in gases. Okay, and then aerosols are the best examples here. Okay, now let's see the third type. I hope you have understood this. Now we are going to see third type, that is gaseous solutions. First of all, it will be gases in liquid, gases in solid, gases or gas in solid, then gas in liquid, then gas in gas. Okay, so gas in gas solution. Okay, so let's see the example. Gas in solid is H2 gas is trapped in palladium metal. Okay, it is trapped in palladium metal. So this is, and it forms a solution and is an example of a gas in solid solution. Okay, next we are going to see gas in liquid solution. The example here is carbonated drinks. Okay, as you know, CO2 is generally mixed in cold drinks and it is carbonated. Yes, so this is the mixture of gas and liquid. Okay, it forms a gas and liquid solution. And last one is gas in gas solution. It is the different gases present in air. All the different gases are present in the atmosphere only. So this is an example of a gas in gas type of solution, where all the gases are homogeneously mixed in air. Okay, so this was the type of solutions, types of different solutions. Now we are going to see how to determine the ways of determination of concentration of solutions. How we are going to determine different concentrations of solutions. So there are certain concentrations such as mass percentage, then molarity, molality, normality, mole fraction, that we are going to see in this video. Okay, so first let us begin with the mass percentage. Okay, so now the mass percentage is basic unit which is used commonly, where we prepare the solution of certain percentage. Okay, for example, if I have to first of all, let me give you the definition of mass percentage or formula for mass percentage. Mass percentage is equals to mass of solute divided by mass of solution multiplied by 100. Okay, so suppose I have to prepare a solution 10% NaCl solution. Okay, so what I am going to do, I am going to take 2 grams, 10% NaCl solution I have to prepare 20 grams. Okay, so here I am going to take 2 grams of solute of NaCl and there will be 20 grams of solution. Okay, okay, now how this is 20 grams? This 2 grams, I am splitting this 20 grams here. 2 grams of NaCl plus 18 grams of water. Okay, if I take it like this and multiply it by it with 100, it becomes 10%. Okay, if you solve this, you will get it as 10%. Okay, so this is the 10% of the NaCl solution. So likewise, we prepare percentage of solution and the concentration here is expressed in percentage. Okay, now let us see the next type of concentration, that is mole fraction. Okay, so mole fraction is also used unit. It is not commonly used unit in labs, but still it is used in different chemistry practices. First of all, let's see mole fraction, its definition. Okay, so it is the ratio of number of moles in a particular solution. Okay, it is the ratio of number of moles in a particular solution. If I have to express it mathematically, let's first see there is a solution of A plus B. Okay, A is a component and B is a component. Let's say B is solvent and A is solute. Okay, so if I have prepared the solution of A plus B, now the mole fraction, if I have to state the mole fraction of A, then it will be, remember it is denoted by the symbol N. Okay, so the mole fraction of A will be mole fraction of A divided by mole fraction of A plus mole fraction of B. Okay, so it is always, as I told you, it is the ratio of the component, one component divided by the total number of moles of the component. Okay, so the total number of moles of the solution will be N of A plus N of B, means moles of A plus moles of B. This here N here denotes the total number of moles of solution. Okay, so out of that, number of moles of A divided by total number of moles of solution will be giving you the mole fraction of A. Okay, similarly, if I have to calculate the mole fraction of B, then it will be mole fraction of B divided by mole fraction of A plus mole fraction of B. Okay, so here it will be the mole fraction of B here. Okay, so remember one important thing, the mole fraction is always calculated within 1. Okay, from 1. So it is always within 1. Okay, so mole fraction is always less than 1 because the total of the mole fraction is always 1. So it is calculated in 1. See here, since on the top there will be a unit of concentration and below also there will be a unit of concentration. So it gets cancelled out and therefore the mole fraction will have no unit. Okay, it is having no unit. So whenever you express certain concentration in mole fraction, it will not have any kind of unit. Okay, so this was all about the mole fraction, and it is widely used in certain calculations and experiments also. So now let's see the next calculation or concentration of solution, that is unit of solution, that is molarity. Okay, it is denoted by symbol capital M. Okay, so see, this is very important because this is very useful for the students. May they have been in 12th standard or in BSc graduation and all. It will be helpful for them. Okay, so let's see what is molarity. It is one of the widely used unit here. So how to define molarity? Molarity, it is the moles of solute divided by volume of solution in liters. Okay, so moles of solute divided by volume of solution in liters. Okay, suppose I have to prepare 1 mole of solution. Any solution I have to prepare, it is 1 mole. Then I have to take the molecular mass. I have to take molecular mass of that solute and dissolve that molecular mass into volume of solution in 1 liter. Okay, I have to dissolve that molecular mass in 1 liter, then I will get the 1 molar concentration of that particular substance. Okay, for example, let's see the molar mass of NaOH, that is 40 grams. Okay, you know NaOH. Yes, sodium it is 23.5, then oxygen 16 plus 1. Okay, so roughly it comes out to be 40. Okay, so whenever you mix this 40 grams in 1 liter solution, okay, whenever you mix this 40 grams in 1 liter solution, you are going to get 1 molar solution of NaOH. Okay, so remember, this is the way of calculating the molarity. Now how are you going to calculate the mass of moles of solute? Okay, suppose you have been given certain amount of substance and you are not knowing that what is the moles of that substance. Okay, for example, you have been given 36 grams of water. Okay, you have been given 36 grams of water. You have to calculate how much moles of water is given to you. Then you are going to use a formula called as moles, number of moles is equals to mass by molecular mass. Mass by molecular mass. Okay, so here the mass given to us is 36. Okay, now we know the unit of molecular mass is grams per mole. Okay, now we know the molecular mass, that is molecular mass is for water is 18 grams. 18 grams. Okay, so when we calculate this gets cancelled off and it becomes to So 18 to the 36, okay, so it will be 2 moles, okay. So we have been given 2 moles of water. Likewise, you can calculate the number of moles of particular substance that is given to you, and when you mix it in a particular, solution in liter, we get a molarity of solution, or we get 1 molar solution when we mix, and 1 molar of solute when we mix molecular mass of substance into 1 liter. It exactly becomes equal to the 1 molar, just like I showed you in the example of NaOH. Okay, so this is how you are going to calculate the molarity. You are going to calculate the molarity here. So the unit of molarity is moles per liter. Okay, how much moles you are dissolving per liter, it is the unit of molarity, or concentration. Molarity is unit is moles per liter. You can write it as moles per liter inverse, moles liter inverse, or you can also write it as moles per liters. Okay, like that also you can write it. Okay, so this was all about the molarity that we saw now. Now we'll be moving towards the next unit, that is molality. Molality is always expressed or denoted by a symbol small m here. This is the 4th concentration unit that we are going to see here. So how to calculate the molarity? Molality, m, small m, is equals to number of moles of solute divided by mass of solvent in kg. Okay, here you have to take the mass of the solvent in kg. Remember, I already told you in the last molarity section where how to calculate the moles of solute. Okay, so it is mass by molecular mass. Here the mass of the solvent should be in kg, remember. Okay, so whenever I have to prepare 1 molal solution, then I have to mix molecular mass. Why molecular mass? Because molecular mass is always 1 mole. Okay, we know that a molecular mass of substance is always 1 mole of substance. Okay, so we have to mix molecular mass in 1 kg of solvent. Okay, so similarly, if I have to prepare 1 molal NaOH, then molecular mass is 40. I have to mix this into 1 kg of water. Okay, 1 kg of water. When I mix it, it will be a 1 molal solution. Okay, this is how you are going to calculate the molarity, or molality. This is how you are going to calculate. Okay, one important thing to remember here is, in case of molarity, the solvent is taken in liquid form. Okay, so when the temperature is increases, then there will be a fluctuation, because solvent will get evaporated and some of the part of the solvent will be lost. Okay, so due to this there will be fluctuation in the concentration, but here in case of molality it will not be there. So because the solvent is taken in kg, its weight is taken. Okay, so therefore molality is more preferred over molarity due to this reason. Okay, so now let's see the next unit, that is normality. I hope you are understanding this. If there is any question, please do comment in the comment section below. So now let's see the next important unit, that is normality. Okay, normality, and this is denoted by capital N. Okay, this is denoted by capital N. Okay, so the number of moles or gram equivalents. How we are going to take this? When we dissolve gram equivalents of solute or mole equivalents of solute into 1 liter, then it is into liters, then it is called normality. Okay, so it is mole or gram equivalents in liters. When it is taken in liters, it is normality. Okay, so now let us see first what is equivalence. What is the equivalence meaning here? Equivalence means number of moles of reactive units in a particular salt or particular substance. Okay, or a compound. Okay, in any compound, the whole compound may not react. Okay, so the amount or the part of compound which is reacting, or the number of moles of compound which is actually reacting is called as equivalence, or gram equivalence, or mole equivalence. Okay, so let's see how this will be used in molarity, calculating normality. First of all, we are going to see what is gram equivalence. Okay, let's see what is gram equivalence. When you take weight of solute in grams, you take, when you take the weight of solute in grams and divided by equivalent weight, then it is called as gram equivalence. It is converted into gram equivalence. Okay, suppose you have been given certain amount, for example 30 grams of certain salt. Okay, so you have to convert this into equivalence weight. So you have to divide that weight of the solute by the equivalent weight. Okay, I'll give you an example here. See, NaOH, suppose. So what is equivalent weight? When your equivalent weight is when you are calculating the mass without actually taking the number of the atoms present. Okay, here NaOH, these are all single quantity, one atoms are there, so it will naturally, it is going to be 40 grams. Okay, the equivalent weight. Okay, suppose if I have to calculate for water, the molecular mass of water is actually 18 grams, the molecular mass. But if you have to calculate the equivalent weight, it will be 16 for oxygen plus 1 for hydrogen. Okay, it will be 17 grams. Okay, so the equivalent weight, and this is molecular weight, this is equivalent weight. Okay, so the equivalent weight for water is 17 grams. Remember, while taking the equivalent weight, you have to calculate the mass of only each atom, each single atom present in the formula of that particular compound. Okay, and when you divide the total number of weight by equivalent weight, you will get the gram equivalence. Okay, now let's see how to use this gram equivalence in calculating the normality. Okay, I hope you have understood what is gram equivalence. So normality is equals to gram equivalence. Normality is gram equivalence of the solute divided by volume of solution in liters. Volume of solution in liters. Okay, so whenever you dissolve gram equivalence of a particular substance in volume of solution that is taken in liters, it changes into normality. Okay, so this is the unit which is generally used in different practical experiments. Here I will tell you the certain relation of normalities. Normality is generally equal to molarity into N. Okay, this is the relation in which converts the molarity into normality. Okay, into N. N is the number of moles of solute here. Okay, so now again, normality, if you have to calculate for acids and you know the molarity of particular acid, okay, then normality will be molarity of that particular solution of acid multiplied by its acidity. Okay, suppose you know the molarity of a base and you have to calculate the normality, then you have to multiply it with its basicity. Okay, you have to multiply it with basicity. Okay, so this is how you are going to calculate all the different concentrations that are used in biochemistry or any kind of life sciences laboratory. These concentrations will be very helpful to the students, as I have explained you here. I hope you have understood all the different concentrations that is being taught here. I have, I think, covered 5 different concentrations that are regularly used in chemistry lab. So I hope you have understood this. If any doubt, please do comment in the comment section below, and please do subscribe the channel. Thank you for watching.